Imagination will carry us to worlds that never were, but without it, we go nowhere.
Den interplanetære podcasten. Utforskning av rom til fordel for hele menneskeheten. Dine verter I England og Norge. Matthew Russell og Chris Carney.
Oh yeah, baby, Carl Sagan. Carlos.
It's Carl Sagan's birthday on the 9th of November.
Wonderful, man. Wonderful. We should a man to be
Wunderbar.
Celebrated. Yes. Wunderbar indeed.
Absolutely. Carl Sagan, what an awesome fella.
The finest of men.
Very, very cool. Not only Carl Sagan's birthday, it's also the 15th anniversary of the launch of ESA's Venus Express.
Nice.
But there's so much to talk about this week.
Oh, yeah.
I've got a pretty crazy guest as well to stick on at the end.
Yeah.
Tim Chrisman.
Oh!
And he's the founder and executive director of Foundation for the Future, which you can find at www.climb2.space. That's the number 2.
Is that all about the plan of putting a cable up into space? Is that what he does?
It is, yeah. So he is talking about space elevators.
Wow. That is amazing stuff.
Yeah, he puts forward a case for it, and I kind of enjoy the case. But we'll talk about that after the interview plays, which is obviously later in the show, old bean.
Oh, I'm so excited to be here, though.
Well, I'll tell you what's exciting.
Yep.
This week was the release of a paper that revealed for the first time an FRB captured within the Milky Way.
Incredible.
Since the start of the podcast, FRBs have become more and more of a thing in astronomy. And it amazes me that in the year 2020, yet there's still all these amazing discoveries going on in space. I just think that's really cool, and that we're making real progress in trying to find out what these things are. And the more we look at them, the more crazy these objects become.
Just for the folks at home, would that be a fast radio burst?
A fast radio burst, yeah. Although I'm not quite sure whether this was a fast radio burst. It's not as powerful as they normally are, but that might just be the fact that the only ones we see from distant galaxies have to be powerful for them to arrive here. And so if there was weaker ones like this one out in further galaxies, we might not detect them because they're just too weak. And when I say weak, these things are absolutely ridiculous, like trillions and trillions of times more powerful than the sun and stuff like that, and would power mankind for eternity in a fraction of a second.
What?
That's how much energy is being released. They're just ridiculous. They're ridiculous things. Yeah, so it's been detected. A fast radio burst has been detected within the Milky Way. It's so intriguing because it means that there's just so much more information about what they potentially are. So they know that this particular fast radio burst actually came from a magnetar that they know about. And this magnetar, SGR 1935 plus 2154.
Catchy. But what is a magnetar?
What is a magnetar, huh?
Yeah,
huh?
yeah.
Well, a magnetar is a type of neutron star. So imagine a neutron star. When it's formed, it may actually inherit some of the magnetic properties of its host star. But remember, a neutron star is something that's like 2 times the mass of the sun, and it's shrunk down to the size of Manhattan.
Yeah, I like to go back to the little teaspoon of matter.
Teaspoon weighs Everest, yeah.
Yes, yeah, I love it every time.
Absolutely ludicrous thing in the first place. But can you imagine that the star itself is spinning, and just like an ice skater, that when they're spinning on the ice with their arms out, when they squeeze themselves up into a little ball, they spin faster and faster and faster.
Amazing.
Because of the conservation of momentum, of course,
Yes.
which you know all about, Chris.
Yeah, well, that's it. That was my paper I wrote on it.
So imagine a star twice the size of the sun shrinking down to Manhattan. It's going to have quite a lot of spin.
Yeah.
More spin than an ice skater.
Definitely more. That's what my paper was about.
Your paper was, does a neutron star spin faster than an ice skater?
And the answer was
and
yes.
Your conclusion one, yes, it does. Yes, it really does. So this neutron star, imagine it was this unbelievably dense object, and so dense that instead of being made of atoms, it's made of just the cores of atoms, and so it could be considered like an atom in itself, like this ginormous atom, just the core of a ginormous atom, and it's just very, very dense, but spinning very, very fast, and this kind of metallic neutron material all sloshing around inside. And the way that it's sloshing around starts to act like a dynamo. And this dynamo obviously builds up all these electric fields and magnetic fields to the point where you get this ridiculously magnetic object. So if it's spinning fast enough, it creates this dynamo effect. Just like the Earth does. You know, the Earth is spinning, and because it's got this molten core, it creates a magnetic field because there's these crystalline molten iron rotating in the center of the Earth, creating magnetic fields, which is incredible in itself. But imagine that on a much more ridiculous level, where you've got a smaller object but much, much, much more dense and made of a much more mysterious substance in the middle of it, and it's generating these ridiculous magnetic fields. The magnetic field is so strong that atoms themselves, you think of the classical view of an atom, where you've got the nucleus and the cloud of electrons making a ball shape. Well, near a neutron star, the magnetic field lines stretch those atoms out so they look more like spaghetti.
Ooh.
And it does things like splits X-ray photons in half and then merges them back together. That's how powerful these magnetic fields are. One of the effects of these magnetic fields is that all this energy is leaking out of the neutron star and slowing its spin down.
Right.
Neutron stars are known for their regularity, but the regularity of the magnetar has been ruined by these magnetic fields that are sort of erupting absolutely everywhere. And just like the sun has solar flares, they think that these magnetars have these flare-ups as well, where you might get a crack in at the surface as it's spinning around, and then and all these magnetic fields. Suddenly, there's a crack in the surface, and loads of X-rays escape, and so there's all sorts of stuff going on. I mean, when you start thinking about neutron stars, they're just ridiculous because the surface is spinning so fast, you get relativistic effects, and the gravity is so much, you get relativistic effects. So everything is crazy, crazy complicated and just extreme.
A lot of the things that we're talking about here, a lot of the sort of features of your magnetar sound similar to what a black hole can do as well. Like, because we talk about spaghetti, and I didn't just get excited there because I really like pasta. It's because I was thinking about spaghettification when you enter a black hole, and then also, you know, about relativistic effects. So basically, is it somewhere between? Could you say it's somewhere between a neutron star and a black hole? Like more powerful than one, less powerful than the other.
Well, I don't think, no, because it's not like, I tell you what is a sort of intermediary stage between a neutron star and a black hole is a thing known as a blitzar.
Oh my goodness.
So a blitzar is a pulsar that's spinning, that's really massive pulsar that's spinning fast enough that the centrifugal force is preventing it from collapsing into a black hole.
Wow.
So like you can imagine that it's spinning around, and so it's not quite collapsing into a black hole, but as the spin slows down, eventually it suddenly goes, whoa, here we go, we're turning into a black hole.
Yep,
That's actually a candidate for other types of FRBs. Maybe it's these blitzars that just as they kind of get to the end of their life, they sort of collapse into a black hole. But yeah, no, the spaghettification of atoms is caused by magnetic fields rather than the spaghettification that is caused by black holes, which is caused by tidal forces, i.e. as your feet approach a black hole, the gravity that they're experiencing is actually far greater than your head, and so you get pulled apart, which actually happens near any gravitational body, you get gravitational forces. If the moon gets too close to the Earth, it would get torn apart. And they think like Phobos will get torn apart as it gets nearer to Mars. And that's what causes rings around planets often. I think it's called the Roche limit, where an object gets too close, it will get torn apart by tidal forces. Same with black holes. But if a black hole is big enough, like these enormous ones at the center of galaxies, supermassive black holes, if it's a big enough one, you don't get spaghettification because the gradient of gravity isn't as high. So in actual fact, you could approach a black hole, one of these supermassive black holes, and not get spaghettified and not even notice that you're crossing the event horizon.
What? That goes against everything I've learned.
I know.
But the thing is, like, I've got quite small feet, so if I got dragged there a little bit, might make my feet a little bit bigger.
Yeah, well, I suppose you could avoid spaghettification if you go flat on to the gravitational field.
Okay,
so that you're not sort of going spaghetti shaped in the first place. If you go pancake shaped in the first place, you might actually be all right.
I'm going to try that then.
I don't think heading towards a black hole or even a pulsar is a particularly clever thing to do.
No, I don't either, really.
In fact, I think you probably would get. I think you probably would get slightly spaghettified as you approached a pulsar as well, or a neutron star, because the gravitational forces on that are pretty extreme.
So mild spaghettification.
Mild spaghettification, yeah. It wouldn't be nice, but but undoubtedly the magnetic field would kill you first, because all your atoms would have been spaghettified, and God knows what that does to chemistry. Presumably all chemistry breaks down at that point, and so just doesn't work.
Yeah, I think we need to rethink this, don't we? If we're going there, we're going to have a little think about it.
Well, it's actually really interesting how magnetars were actually first discovered. So they were actually discovered by accident in 1979.
The year I was born?
1979.
A month before I was born.
Wow, there you go. So magnetars, the knowledge of magnetars is the same age as you, Chris. Isn't that amazing?
Just a little bit older.
So, the Venera 11 and Venera 12 Russian spacecraft had dropped off the probes that went into Venus, but those two space probes carried on a sort of elliptical orbit in the solar system. And they were the first to receive this pulse of gamma radiation. Obviously, this radiation level was absolutely ridiculously high, and it saturated the equipment very, very quickly. And then it went on to hit loads of other spacecraft. This was a sort of pulse of high energetic or hard gamma rays, 100 times more intense than any previous gamma ray burst that they'd ever detected. And everyone's thinking, what the heck is that? And they lasted just 0.2 of a second. So this isn't to be confused with fast radio bursts, but it's a very similar phenomena. Of just, very, very high, intense light, basically. But they were followed by a fainter glow of lower energy gamma rays and X-rays. And then that sort of faded over 3 minutes. So there was this one big pulse and then some pulses of other information. And that period, sort of the oscillation was about 8 seconds, and that was the first clue about what these things were. Chris Thompson, who was at high school about in 1979, so not as young as you, he went on to write a paper with this guy called Rob Duncan at Princeton University, and that was 1992, and they were the people that coined the phrase magnetar.
And that was when I was at school, at high school. So, I mean, the story of the magnetar and the story of me is just running like side by side.
It's linked with your life, isn't it? Really? So they'd been thinking theoretically about what happens in neutron stars and how they inherit magnetic fields from their parent star, and then how this rapidly spinning liquid, crazy dense matter crystals all sloshing around, creating all these ridiculous magnetic fields. So they'd been working out, what that actually meant, and they realized that that it would slow the neutron star down, the spin down, but would do it in this really erratic fashion. So neutron stars are known for being these amazing clocks that you can use them as standard candles and sort of say, that is a neutron star, and its pulsing is actually, they're thinking of using them for GPS. But magnetars are absolutely completely different. They're neutron stars, but they're kind of out of control a little bit because of these ridiculous magnetic fields. So But this 8 seconds was a clue, because that's the sort of glitching speed of these neutron stars. And so that was one of the things that they kind of linked up and said, that 1979 event was a magnetar, and it all sort of tied in, and everyone went, whoa, that's really cool. And so, yes, they, over the years, they found about 30 different magnetars in the Milky Way or thereabouts.
I've just learned something new today, which I really like. That's magnetars has entered my knowledge base, which is fantastic. It's just fascinating stuff.
Neutron stars, other than black holes, are the most extreme objects in the universe. But the good thing about neutron stars is that you can actually see them, whereas black holes, by their very nature, you can't see what's beyond the event horizon. Whereas neutron stars, that can obviously be pulsars, magnetars, blitzars, all the sort of variations of these crazy objects, they are physically there to actually study and see, which I think is really exciting, because there's presumably so much crazy physics going on, including, sort of particle physics, the fact that you've gone down to the neutrons, and maybe at the core of these neutron stars are sort of quark soups and stuff like that. So it's a real, it's where cosmology, the sort of study of the massive universe, is also the study of particle physics as well.
Quark soup, though.
Oh. I suppose you can actually make quark soup, couldn't you?
Yeah, you can.
That sort of cheese, couldn't you? Yeah. It's like is it a British thing, quark?
Quark,
sort of soft cheese, isn't it? But
yeah, I think so. Yeah, I would say it is. Yeah. Cheese soup.
I don't know. I would have to cheese soup, quark soup. Might make quark soup. Now we've thought about it. What about fast radio bursts? So fast radio bursts. We did a sort of big dive on podcast 137.
I remember it.
Not you and I, Chris, but
I know.
Myself and Jamie.
The wonderful Jamie
myself
Franklin.
And Jamie.
Yes.
Wonderful Jamie Franklin, who's got some amazing news.
Ooh.
Jamie, what a ledge.
Total ledge.
We've been talking about them because there's been some little sort of snippets of FRB information coming in. So FRBs were sort of first spotted in 2001 in Australia by the Parkes radio dish. And it was just like this one burst. It went, yet it was incredibly powerful. And it was tracked down to some region of the small Magellanic Cloud. Magellanic?
Magellanic.
Presumably it's named after Magellan.
Magellanic
Cloud. I don't know. But when they looked, there's nothing to see there. They couldn't see what was causing it. There was no optical gamma ray, infrared radiation or anything. So it was incredibly powerful. Then they thought they were spotting loads of these things. There were 16 more in 2010. But it turned out that was all people opening their microwave ovens.
No.
So when you open the door when it's on. Yeah. So the microwave oven has a magnetron tube, which should have been a clue, right?
Yeah.
That's got a magnetron tube in it. And when it's powering off, it releases a fast radio burst that these very hypersensitive radio telescopes were picking up. And
so they thought we were getting loads of these FRBs, and what was actually happening is people's microchips were ready.
Microwave oven, yeah.
Oh, that's great.
Yeah, I know. Unlucky, isn't it? I mean, imagine if you'd written like about 5 or 6 papers only to find that out. But in 2015, Paul Schultz of the McGill University in Canada found 10 non-periodically repeated fast radio pulses in the archival data of the Arecibo radio telescope, including FRB 121102, detected in 2012. So 12 is always the year, the first two digits of the year of the fast radio burst. And that was the first repeater discovered. So this first repeating FRB gave astronomers the chance to kind of hunt down the source. And they realized it's a star-forming low metallicity dwarf galaxy located roughly 3 billion light years away.
Wow.
By looking really carefully, they found this dimmer persistent radio source in that region. And that was a real massive hint that FRBs were powered by magnetars. And so that's when they're kind of really homing in on it.
It's just amazing.
And they also realised that it couldn't be like a cataclysmic event either. So it couldn't be two neutron stars crashing into each other, because it wouldn't repeat, obviously, unless you had a kind of neutron star gun firing neutron star bullets.
Or a game of neutron star pool.
It seems unlikely. And also, another repeater was found, which ruled out aliens, of course, because it could have been aliens trying to communicate with us, which is, as you know, it never is.
No. Apart from with the wow signal. The wow signal, I'm still holding out for that one.
Yeah, well, maybe. Just maybe. It's really tantalizing that we finally found an FRB in our own galaxy.
Yeah.
And it is a magnetar. They know that this object is a magnetar, and that they've actually had this ridiculous signal. So we should actually say how they actually got this signal. So this signal was on the 27th of April, and it was first picked up by NASA's Swift telescope. So that orbits twice as high as the ISS. So, in fact, the Swift telescope didn't actually spot the FRB. It received this kind of just a normal gamma ray stream from this magnetar. So when I say normal, obviously it's not normal. So this thing's like pumping out gamma rays just like neutron stars do.
Yeah.
And then the next day, the Canadian CHIME telescope, which looks like a bunch of discarded curved metal fencing parts just lying on the ground.
They're so messy, aren't they, the Canadians?
I think of Canadians as being very neat.
They just apologise a lot as well. Yeah. Oh, sorry, I made this a little bit messy. Sorry about that.
Sorry about that. They picked up this much more exciting, much more intense burst of energy. But even more excitingly, so did this radio telescope that's basically two parts, one in Utah, one in California. And all these are just metal poles with, and I kid you not, a cake tin on the top, apparently. That's what these telescopes are. Literally, a metal pole with a cake tin on top.
This always comes back to food.
Yeah,
Why does it always come back to food?
Well, because obviously astronomers are greedy. They just sit by a telescope eating cake. So they have lots of cake tins lying around.
Ready.
And so they actually saw this big burst as well. And so we're able to say, yep, this definitely happened. And the FRB was associated with all these weaker signals coming off this magnetar. So it contained all this information that you wouldn't normally get, because these weaker signals that come associated with that obviously don't survive the intergalactic distances these FRBs have normally gone over.
So what you're saying is we're getting it at a sort of higher power than we would get from the outside of the galaxies. It's now, because it's within ours, we're seeing a lot more of the energy from it and able to know more about it as well, which is obviously the aim. That's great.
Yeah, exactly. It's just the fact that we've got something that's more evidence that it's a magnetar, that these magnetars, that magnetars really are a thing, and that they're following the kind of maths, the sort of bottom-up approach, so that all these hypothetical and theoretical, the maths is sort of coinciding with what astronomers are seeing. And I love that. I think that's science at its absolute best.
Peak science.
But the only caveat is because I was, when I first started reading, I was thinking, well, that's it then. So FRBs are just well, when I say are just, FRBs are magnetars. That's what they are. But this burst apparently was thousands of times less energetic than these other FRBs that we've been seeing. And some of these distant repeaters aren't as easily explained as coming from magnetars. So it's not case closed. So we know that some of these FRBs are almost certainly magnetars, but maybe not all of them. You know, they could be these blitzars. They might be dark matter-induced collapse of pulsars. They might. The most speculative is the explosive decay of axion mini-clusters.
Which is?
Axions being a kind of... Well, an axion is a sort of hypothetical elementary particle, and would explain quite a lot of things about the universe if they were true. But of course, no one's ever seen them, so that's that. And it's the same with cosmic strings as well. It could be cosmic strings interacting with plasma and all those kind of things. So there's a whole load of speculative things about FRBs. But I suppose, you know, eventually the maths will turn out, and I think it will turn out to be all neutron star related. You've got these crazy objects that are capable of this amount of energy and putting out this amount of energy, and I think that's what it will all end up being. That virtually all the FRBs we see will be from various types of neutron star activity. One of them being magnetars, maybe blitzars. Who knows?
Oh, it's just mind blowing
or
stuff.
Hyperflares.
Yeah,
hyperflares.
Absolutely
magnetars.
fantastic.
I mean,
just really just mind blowing stuff, and it's incredible to learn about. It really is fantastical.
But I just love that this is actually all quite new as well. That astronomers are sort of discovering all this stuff now. This is all being discovered now.
Yeah,
how cool is that?
Yeah, totally. In our lifetime, and yeah, it's things like it seems like that this sort of knowledge and discovery is accelerating as well, which is just it's amazingly exciting to see what's going to be coming over the horizon as we just get better and better at these things.
Yeah, I mean, well, I suppose now we're looking for them as well, and we build better and better radio telescopes and all these enormous radio telescopes that are coming online, and presumably better spacecraft as well. We'll start to see some amazing stuff, I'm sure.
Yes.
It's going to be an amazing... The next 20 years in astronomy, I'm pretty certain, are going to be absolutely incredible.
And the next 20 years of the next 20 years of the Interplanetary podcast will be similarly exciting.
Well, yeah, exactly. Well, the episodes write themselves.
Premium content.
Yeah. Yeah, imagine if if you were stuck doing a podcast about, I don't know, what's a dead subject that has
phrenology.
Yeah, if you would phrenology. Yeah, it'd be interesting for a few episodes, and then it'd be like, well, what do we talk about now? Yeah, we'll just have to go back to the beginning.
So it could also be Betamax videos. Any new discoveries about Betamax videos today? No, sorry, Matt. Nothing on the horizon.
Actually, do you know, because people might say, well, what's the point of knowing about FRBs? The thing I love about FRBs, by the way, is the fact that they almost act like a beam of light that goes through the universe, and you're able to sort of see how the universe is made up between you and the magnetar. This thing called tomography. You know, when you see medical programs where they're doing slices through the brain using MRI scans, it's a bit like that these magnetars are sort of revealing space in these cross-section slices as it goes, as they shine through the galaxy or shine through the universe. Amazing. So that you can actually see much more about what the universe is made of and how it's made and its structure. So they're really useful things.
Because it's going to sort of maybe like help for some of the theories, like string theory, like really these things, the more we know about these, the closer we could get to having a theory of everything.
Well, yeah, or certainly what they can do is rule out certain theories of everything.
Yes, yeah,
because it's like if they behave in a certain way and that doesn't fit the theory, then it's like bye theory.
Yeah,
and that's that. Or or you have to modify the theory so that it takes these crazy objects into account. I mean, yeah, they're like laboratories. They're like laboratories that are happening out in space doing crazy physics for you.
Yeah,
right there.
The universe has given us massive hints.
Oh, yeah, because if they weren't there, you wouldn't be able to know all these things.
Yeah.
God, the universe is absolutely ace.
It's so good, isn't it?
So cool. I'm going to come back to Earth a little bit, or nearer to Earth, and talk about a couple of space missions to the moon.
Cool. Love it.
Which I think, actually, they're both very exciting indeed. The first one that I read about this week was the United Arab Emirates are going to the moon. So they've sent off, obviously, their spacecraft off to Mars, which is pretty exciting. But they announced this week that they're going to build a rover, a 10-kilogram rover, that's significantly lighter than the Chang'e 4, for example, which is about 10 times bigger. They're going to call this the Rashid, after Sheikh Rashid bin Saeed Al Maktoum, who was the ruler of Dubai in the creation of the United Arab Emirates back in 1971.
Yes.
They're going to get an international partner to launch and land it, but they're going to 100% build it in the United Arab Emirates. So that, of course, they're really building their skill set up. So UAE are really, really serious about their space ambitions. In the last decade or so, they've gone from nothing to being like a proper player. In space. It's really, really impressive. So yeah, they hope to land it in 2024, which of course is when everyone else seems to be going as well.
It's going to be busy up there.
It really is. Actually, we should mention Artemis. And of course, congratulations to Joe Biden for winning the American election, or at least it looks like he's won the American election.
He's won it.
That way. He's won it. Well, he has won it.
Yeah.
So, congratulations to Joe Biden.
Very much so.
I think, unfortunately, that might. Well, according to Eric Berger, it was the end of Jim Bridenstine anyway, but it's obviously almost certainly the end of poor old Jim Bridenstine. And of course, I suppose it could be the end of Artemis as well. Although Joe Biden might think to himself, actually, do you know what? This might look good under my presidency as well to have.
I think that
happen.
He never really had much of an interest during Obama years, but I think apart from the fact that obviously a lot more resources going to go into likes of climate change and obviously COVID and stuff like that with regards to science plans, I think I've got a good feeling he's still going to be very positive towards this. I know it's like one of the few things that has been beneficial in the Trump administration, but I think he'd be silly not to carry it on because the rest of the world is just going to start progressing so quickly that, he doesn't want to end up at the back of the race on this one.
There has been something to be said about the kind of Trump administration's kick-starting, I guess, the Artemis and going back to the moon and making it a thing. And now it's in play, I suppose it's almost a little bit unstoppable. I don't think it's going to happen in 24. Well, I don't think humans are going to be landing on the moon in 24, but I do think we're going to see an absolute ton of missions to the moon. That the moon is suddenly, like, it's been opened up. Well, it's been opened up by commercial space anyway. The fact that people can get on a Falcon Heavy, for example, and send a reasonably large payload to the moon. So yeah, it should be very, very exciting. So that, I'm really looking forward to the next few years. But before then, and the one thing that I really hadn't clocked until I was reading this is the Chinese plan to go to the moon. So this is the Chang'e 5. So obviously the Chang'e 4 last year was absolutely epic because it went to the far side of the moon
with some potatoes.
The first, the first object ever to do it and land there safely, and it's been working there ever since and doing amazing science, including potentially growing things on the moon for the first time, which is amazing.
Yeah.
But this is a mission that has been delayed from 2017. So the Long March 5, which was the success story of December 2019, when they and since then, obviously, since they launched it in December the 19th, they've sent an orbiter to and lander and rover to Mars, and they've tested their manned capsule with it. So the Long March 5 seems to be all fixed now after its disaster that stopped the Chang'e 5 launching in 2017. But what's going to be amazing about this mission, it's going to be over but before the end of the year. We're not talking about one of these missions where we talk about it and it launches and then we have to wait 10 years before we get anything. This is like this will be over by Christmas. So we'll know whether this worked or not. And it's very, very ambitious and it's super exciting.
Yeah.
So you got Chang'e 5. It includes a lander and an ascent vehicle, an orbiter and a returner. So it's going to go to the moon. So it's going to launch on the 24th of November from Wenchang. And of course, we'll have the extra bonus excitement about whether bits of the Long March 5 will land on American cities. Like the last one, which narrowly missed a couple of American cities and landed on the coast of Africa somewhere.
Oops.
Which is just insane. I mean, literally amazing. I mean, the Chinese just don't give a monkeys about where their bits of rocket are going to land, including on their own people. Just like literally mental. So so we get that bonus. We get the bonus of the excitement of possible.
Are we going to die?
Multiple deaths and stuff. Are we all going to die? Oh no! It's landed on a nuclear power station. That would be unlucky, I have to say.
Oh shit! Yeah. Excuse my language. Though.
So Chang'e 5, is going. So it will go to the moon. So it launches on the 24th of November. It'll take a few days to get to the moon after being, in a low Earth orbit. It'll go off to the moon. It will go to a place called the Mons Rumpke. This is what Harold Heisinger of the University of Munster said.
Yeah.
He said, the landing site was extremely wisely picked. And we'll get on to why in a second, but Mons Rumpke, a 1,300 meter high volcanic complex in the northern region of Oceanus Procellarum. So that's where it's going to land.
Procellarum.
And then it's going to drill 2 meters down, scoop up 2 kilograms of moon regolith with its robotic arm, place it into a canister on the ascender vehicle, and then it's the ascender vehicle. And by the way, all this has to be done in the 14 Earth days, because 1 day on the moon lasts 14 Earth days, and then you go into super cold nighttime. Like the nighttime on the moon is brutal, and the UAE rover probably won't survive it. So that's only going to be a 14-day mission. But this one is going to scoop up some regolith as quickly as possible, and then the ascender vehicle will go back into lunar orbit and rendezvous with the returner craft, a bit like the Apollo 11 mission, in the same way that Buzz and Neil took off and rendezvoused with Michael Collins up in lunar orbit. This is going to do a similar kind of trick, which of course for the Chinese is brilliant because it means that they get to practice that type of maneuver for their human missions, which they plan to do in about 10 years' time.
Fair play. This would be a brilliant room in the Crystal Maze. just all the things that you've got to do when you're in there. Come out! just like loads of Chinese guys poking through the hole, just telling them what to do. Dig down, 2 meters. Yeah, with your robotic arm. I think you need to use the robotic arm.
That's it. Yeah, it is. And so we'll wait to see. But the best bit about this is obviously this all happens really quickly. So that the Chang'e 5, then if it's successful in scooping up rock and then getting it to the returner, is going to come back to Earth and parachute into Inner Mongolia by December. So we'll know whether this was successful before Christmas. So the Chinese are actually going to go and get some moon rock before Christmas. How cool is that?
Cracking Christmas present.
The Chinese are the only nation that aren't allowed to ask for the Apollo moon rock. So if you were to write one of your brilliant papers again, Chris, and this time you were to do it on moon regolith and you had a really great idea, you could apply to NASA and say, I really want some moon rock because I want to do this experiment. They'll look at it and go, yeah, that's a great experiment. Here you are, right? Yeah. Chinese can't do that. So these lunar samples are going to come back to the Chinese Academy of Sciences National Astronomical Observatory, or NAOC as you know it, in Beijing.
Yes.
And a small amount of it will also go somewhere else for safety, and some will go for display. But it's probably all going to stay in China.
But that's brilliant for them. So, that's actually great. They're just sort of like going, we've got our own now, sort of thing.
We've got our own now. Don't need yours. Yeah. So I wonder if they're going to open it up to other nations except America. We'll have to wait and see what actually happens. But it's super significant because it comes from a different part of the moon. So this is the reason why this area is really well chosen, because they'll be digging down, and this is much more of a sort of modern, a newer lava flow. And so from this regolith, they should be able to tell how recently the moon was active. So if the moon was active in, say, the last 2 billion years, it really will be a very significant story about the history of the moon.
Yeah. And the history of Earth as well. That says a lot more about life. It's
no, absolutely. We're not only our own system apparently that this moon rock can tell us about Earth and the moon, but it can also help age the other planets. So one of the things they use to date planets is how many craters are on the surface. But of course, with lava flows and stuff like that, it affects how many craters you actually see. So getting material from that exact spot where you can count craters and you can work out when those lava flows were, you've kind of got another reference point for how many craters you get for a certain aged object, so that they can, date other objects from their craterage more accurately.
Fantastic.
So this could be, it's a very important mission, but I think in some ways, other than maybe the Crew Dragon mission, and of course this second Crew Dragon mission is probably just as exciting. This is the most exciting space mission of the year. In fact, it may even be more exciting. I must admit, bringing back moon rock for the first time since the Apollo missions is unbelievably exciting.
It's incredible.
So the Chinese gave us the very Chinese gave us the very, very worst start to 2020, but they might actually go some way to redeeming themselves and giving us an all right end.
We go like that. You brought some moon rock back. Don't worry about that whole pandemic thing.
Well, the worst, can you imagine if they bring moon rock back and there's a deadly virus inside it?
Yeah, I was just thinking that then. I was just going a little bit of a message from the Chinese space organization, sort of going, look, we've got another bit of bad news here. Sorry.
That last virus? Well,
Amazing. But it is, and the fact that we'll know about it by
Any-
the end of the year is superb. Like, that is brilliant. We'll be literally talking about it within weeks.
Yeah. I know. I really can't wait. I really can't wait for that. I just hadn't clocked what that it was all going to be over so quickly. I love it because normally these missions take forever.
Yeah.
To actually bring results, and then actually even longer. Even when the mission is finished, some of the results you don't get back for decades as people pour through all the data.
Yeah.
So yeah, it's really exciting. Which actually is the case for this one. I'm sure that the moon rock they bring back will be studied for decades.
Yeah.
Chris, would you like to hear my interview with Tim Chrisman?
I would love to, Matthew.
Well, I'm going to play it for you now.
Oh, great.
Ekutai.
The Interplanetary Podcast, putting the ace back into space.
So I'm joined on the podcast by Tim Chrisman, who is the founder of a Foundation for the Future. Welcome to the podcast, Tim.
Thank you, Matthew.
So you're in DC, I hear, at the moment. That's correct, is it?
I am. I'm about 8 feet underground to protect myself from getting too close to any voting.
So we're doing this on the Friday. Hopefully, this will be out on the Monday. So we may know the result by Monday. Who knows?
And who knows?
Right. So, well, first things first. Tell us a little bit about the Foundation for the Future and exactly what it's all about.
Yeah, gladly. So the Foundation for the Future is a single issue advocacy group where devoted to getting governments, in this case, the U.S. government, to treat infrastructure investment equally across all the domains humans are in. So we have water, land, air infrastructure. We need space infrastructure. We shouldn't be depending on single-use rockets, space stations that are 20 plus years old. We want a ecosystem of support so entrepreneurs and workers can just show up, plug and play, just like you would do if you were building a house or starting a business here on the ground.
So is there a historical context to that? Is there a time where someone like you would have been setting up a foundation for the future and talking about going to the Americas, for example, something like that?
Yeah, so it does have a lot of parallels to colonial exploration and development. We have noted that early on and the baggage that's around that, and have tried to lean into it in many ways, because every time there's been a historical analog to this, whether it's colonial times or just hunter-gatherers traveling out to go find new lands, it's always been on the backs of hurting someone or something else. And now we have a chance to basically do it right. We can invest in a new environment where there is risk, but it's to the people going. And so there are a lot of analogies, whether it's colonial times, the American frontier, even things like the Panama Canal or the transatlantic cable. These are things that required more or less private advocacy for public action.
So what is the friction? I mean, so why do organizations like yourself have to exist if? Because it seems to me it's fairly obvious, isn't it, that there's a new frontier. So why is there friction, particularly in America, where you would think that you are very much a frontier nation?
So we've not seen a lot of resistance to our idea. It seems to be one of those situations where everyone assumed someone else had already thought of it or tried it. And the idea has been in most people's heads when we talk, oh, NASA does that, or Space Force will do that. But then once they stop for a second and realize, wait a minute, NASA's ostensibly exploring, Space Force is ostensibly defending. what falls in the middle? We don't want it just being Elon Musk and Jeff Bezos. They don't even want that. And so who is that third entity that can provide some early stage capital through like development bank sort of investments? Who holds everything together with the integration as like a port authority? And where are the researchers that aren't rocket scientists, whether they're law and policy or engineering work for space habitation? There's a need for this, and we've lumped it all into one organization. But in reality, this is the work of 3 or 4 government departments in normal domains.
Yeah. So we'll break down exactly all the sort of key elements then of what that government departments would look like, I suppose.
Yeah, and so the first one, and really the biggest, is this Space Infrastructure Development Bank. So a lot of major countries have these development banks that do loans to the third world to build infrastructure. And the idea is that these are high risk loans, but they have real payoff in terms of social and economic benefits. And this would be modeled similarly, where it would be a partnership between the government and private equity, where the government would assume the first 50% of risk, as well as paying out 50% of the capital, and really start investing in the wild, crazy, ambitious infrastructure projects that aren't economically viable right now, like space-based solar power. It's just too heavy. But if it's done with a subsidized loan, all of a sudden it becomes a societal good where we can use that in disaster relief zones 10, maybe even 20 years sooner. So that's the first part, is this development bank. The second is the Spaceport Authority. Much like there's aviation administrations for most countries, this would integrate the space traffic management, the space launch, debris management, and the logistical integration. At least in the US, and I assume it's similar over yonder, the port authorities are these quasi-governmental departments that basically provide a harbor framework for companies to set up in. And this would be a similar structure where companies would essentially lease harbor space or port space, and this authority would invest in spaceports and the ancillary networks required. And the last element is this Center for Space Studies. So there is plenty of research being done on getting to space, on the hard sciences of space, but then what? The policy review, the analytics of geopolitics, the law, and even some of the integration of advanced architecture and engineering. How do we bring that all together? Because for one, most of these people don't talk to each other, whether just because they're working in their silo or because there's professional rivalry. How do we bring that all together? And we see that being the Center for Space Studies.
Well, yeah. So, there's a lot. There's a lot to break down there, isn't there?
Yeah.
I mean, my initial thought on a lot of things like that is, how do you know that now is the time? And I mean, obviously, if you'd had this lofty ambition 50 years ago, the technology and the know-how just isn't there, and you know it. And now we know, of course, it wouldn't have been there until now. So, what is it about now that feels like it's the time for us to be thinking about these particular things?
Yeah. So in many ways, it's not the right time. You mentioned decades ago. We're late for all intents and purposes. But as with anything, the initial frameworks that are set up whenever anything new starts, in this case, space, tend to persist, and we just add on to them until something goes wrong. And our our pitch is NASA could keep going as it is for another 5 or 10 years. Space Force is standing up. They are probably going to assume a lot of the slack that NASA's not. But is that what we want? We have an opportunity here where we are trying to recover from COVID. We have a new administration, whether it is a continuation of the Trump time or a Biden administration. Either way, it's a new Congress. And both parties have signaled a desire to increase infrastructure investment because it creates these sustainable jobs. And so if we're late for this concept and the sort of vehicle to get this moving is kind of agreement, even though not necessarily on the idea, but on the concept of investment in infrastructure, we view that as being the salient point in the timing. So never letting a crisis go to waste, so to speak.
Yeah, so the foundation is very much US based. So it's very much about, well, or correct me if I'm wrong, it's very much about actually making sure that America or the United States stays ahead of the game. Is that right?
So,
rather than seeing yourselves as something like an Asgardia or something like that, where it's more lofty international kind of, or even beyond international kind of ideals. Yours is much more of a sort of practical, how do we get America into space?
So the short answer is yes. And I've learned in my time doing this, it's always better to answer the question first and then do the long-winded talk about. People seem to appreciate that. So yes, we are US focused in part because we view the US as being a natural leader in space, and of the major space countries, it's the one we would prefer to remain the leader. However, one of the key tenets of this organization we're trying to get Congress to create, the Frontier Infrastructure Administration, one of its 3 tenets is to promote partnership. And that is across academia, industry, and internationally. So whether it is the Japanese company Obayashi that is planning to build a space elevator, or partnering with ESA to make commoditized space launches a thing. We view everyone winning the more people get into space and the more sustainable space is. That's I think I've told a handful of people, we're fine with partnering with anyone. We're even fine accepting help from anyone who's not a communist.
Okay. So it is grounded. It is grounded in kind of I guess traditional American kind of ideals, or even Western ideals, I suppose. Yeah. Currently, what's kind of you've seen as the sort of main challenges to start this pretty big ball rolling?
Yeah. The main challenge has been cutting through the noise in the election. We have made a conscious effort to remain unconnected to any politician or political party, including not talking to any, because if there's one thing we've seen in America the past 4 years, doesn't matter if you have a good idea or not, it's who latched onto it first. That determines whether it remains a good idea. And so if our proposal is looking to create nearly 1 million new jobs across the country, it doesn't matter if the wrong person latches on and says they love it and the other party ends up being in power. So really starting next week is when our political outreach begins in earnest. And that's been the biggest challenge, because instead of being able to really start from the beginning of going straight to the customer, in this case, the Congress, and saying, here's our proposal, what's your feedback, and go back and forth and iterate. We've been building this and only now are getting to do that process.
What do you think these elections will mean? What do you think the kind of political landscape stepping into it is going to be like? Yeah,
so I messaged my team Wednesday morning and said, as it stands, the results look like they have taken our chances of success from inevitable to extremely likely. So they have decreased. And I say that only because there's not a clear party that swept everything. Had that happened, adding our proposal on as an amendment is almost a foregone conclusion, because for one, space has broad appeal. For two, infrastructure investment in general is a good use of federal dollars, and doing it in a space that is completely undeveloped, so to speak, gets you even better returns on your dollars. But we still view this as extremely likely because of those reasons. It just means there's going to be more legwork on our end talking to people instead of needing to get 15 or 20 key individuals on board. Now we just have to do 40. And you know what? It's just 40 people because like that's just more Zoom calls, more in-person meetings. And yeah.
So I kind of get the feeling that what would help is if somewhere in, say, China, there's the Chinese Interplanetary podcast having a conversation with the Chinese equivalent of the Foundation for the Future, yep. and that would sort of wake everyone up and go, oh yeah, we better do something about this. Do you know if there is anything like this anywhere else in the world? Is there somewhere in India? Is there someone in the United Arab Emirates or something like that doing a similar kind of project to this?
Yeah, so definitely in China, they're very cohesive in how they're managing their space program, and we do see them proposing or actually doing research in most areas of infrastructure that we've identified as important. And that's definitely something we are highlighting, whether it's China's plans to build space-based solar power, habitation on the moon, et cetera. All of those are key talking points, depending on who in Congress or the military we're talking to. And that unfortunately is a necessary talking point because in many ways it does feel like a competitive venture, and we need to be able to say, yeah, not only is this a good idea, but they're doing it too and ahead of us. And so that is definitely part of it. In some cases, even countries as small as Luxembourg with their space law and UAE with their new development proposals in space are further along than the US. And that is something we are deploying as talking points. But the sort of look of a cohesive, almost whole of country effort to treat space as infrastructure, I've not seen. Okay, but it does seem natural.
I mean, China would definitely have an advantage there, wouldn't they? Because they're so much more centralized anyway in their entire approach, just by the nature of their system. Well, before let's not get bogged down in politics. So let's. I've noticed that you've already said it a couple of times. You've said space-based solar power, and you've also said the space elevator. So they seem to be a couple of projects that you're behind. So can you tell us a little bit more about your involvement with those sort of ideas?
Yeah, those are two of the projects we've identified as being the sorts of projects that are natural fits for this frontier administration. where they have massive benefits to society and economically, but there's not a clear path to them being viable for private equity to fund. So whether we see space-based solar power being a much easier lift, both in terms of dollars and actual initial operating capacity, but even a space elevator, whether the downside of it failing is we don't have a space elevator. Trying and failing means we establish a network of advanced material foundries and research institutes in a lot of these nanoparticle materials that are good for virtually everything, whether it's single crystal graphene, carbon nanotubes, hexagonal boron. Like, these are super expensive to make now. And realistically, you can retrain most blue collar factory or industrial workers into those jobs if they're unemployed. And now all of a sudden they have a job for life because that's transferable almost anywhere in the world. So I was told early on, don't hang your hat on this space elevator thing because better men than you have tried and failed. And my answer was, I don't care if it's turtles. I don't care how we get into space. We can pile up turtles because it's turtles all the way down. That's what's holding us up.
So why not? Just flip it.
Yeah, just flip it. And the point is, get to space reliably, cheaply, and in the most boring way possible. We don't think how a box is shipped across the world, where it's like, nope, I left it outside my door and it showed up where we're supposed to. And that's what we want for space. A space elevator captures the attention and there's a lot of good imagery around it. But at the end of the day, if there's a better way, let's do the better way.
Yeah, I mean, obviously this plays into, because the one thing, obviously, the States have a massive lead on, and I would say, to the point now where Elon Musk's SpaceX has essentially, it is the rocket industry. Mm-hmm. In the last few years, he's absolutely disrupted that industry.
Yeah.
And it looks like, how does that fit into how do you? Yeah, what's the relationship between the foundation and Musk, Bezos, et cetera, et cetera?
Yeah. So we view them as, so the relationship is not there. They're welcome to join us if they want. But our view is that we're trying to create rail transport to space and they're doing airmail. What we want is never going to replace their rockets. And in many cases, it's going to augment their capability, whether it's with traffic management, debris mitigation, or just investing in more spaceports. So we view that as actually increasing the need for rockets and what they're working on. But also the more people are looking at space and talking about it and trying things, the more opportunity there is for those scale of people, the Musks and Bezos and Bransons of the world, to be able to innovate further and throw money at these other fledgling ideas.
Yeah, so fledgling ideas. I think probably the best way to get my head around exactly where you see everything going is for you to describe, that I guess the next 20 or 30 years, or decade by decade, how you see it unfolding and the foundation's place within that. Yeah.
So the plan is 2021. The U.S. Frontier Infrastructure Administration is funded by U.S. Congress, $10 billion a year for 5 years, after which point it'll be mandated to be self-sufficient and operated as a quasi-private corporation. Over the first 5 years of its life, the investments are largely going to be in quick return sort of projects, the advanced material foundry networks, the spaceport networks, the space manufacturing hubs, and also some that we don't necessarily need right now, but are easy, relatively, wins, like out of orbit GPS navigation. So NASA's done work on pulsar-based navigation receivers. If you don't have to launch GPS satellites, which are billions of dollars, and all you have to do is create a receiver and algorithm to receive pulsar signals, that's a cheap way to dramatically improve everybody's lives as soon as they leave orbit. And so really that first 4 or 5 years is a base setting for the materials, the administration, and the skeleton of whether it is manufacturing hubs in GEO or commercial space station investments, as U.S. government being an anchor tenant. And then from 5 to 10 years, that's when we see a breakout. Our pitch is we can have a Pathfinder car riding a space elevator cable by the end of this decade. And I mean, we went to the moon using a calculator and a prayer. So it's crazy. It's impossible. It's ambitious, and it'll remain all three of those until it's not. And then everyone will say it was inevitable. And so it's that 5 to 10 year mark that the space-based solar power starts coming online with an initial operating capacity for use in emergencies. The elevator system starts work. And even if work is just self-reinforcing, it's still there. And it's this icon that it was done.
Yeah, I mean, I obviously, having done the podcast for a few years now, I know the arguments against the kind of the main arguments against space elevator have always been the materials required, even with nanotubes, they have to be perfect apparently for it to sort of be a viable space elevator, but also the danger of the cable snapping and wrapping itself around the Earth. But the one that I found very interesting recently is this idea that if Elon Musk can make Starship work, then it's actually cheaper. It's a cheaper form of getting stuff pound for pound up into space than the elevator is. How do you normally address all three of those kind of major concerns about things like the space elevator?
Yeah. So the first, the material one is, yes, it does need to be as close to perfect as probably possible to be, just to get it that long. And our view is yes, and right now the issue, we can make, for instance, single crystal graphene. It can be made roll to roll in a continuous roll. Nobody makes it very long because you don't need it very long, but we can do it. But the problem is it's fairly slow. It's a handful of meters an hour, which would take a long time to make the cable. So our view is the problem's not the material, because if it's not perfect, we can iterate on it. The problem is making it long enough. The second issue with the cable snapping and damaging people and the like, that is a concern. Depending on where it snapped, it could become a problem. For the most part, if it snapped, the anchor at the top is going to pull everything up and out, and it would probably damage a handful of satellites on its way out. on the downside, below the break, the material's light. For like single crystal graphene, the entire 100,000 kilometer roll would be about 77 kilograms. So, yeah, it would fall, but it would also not be terribly damaging unless it hits you on the head. Our plan is to base it in the Pacific along the equator. And so there is a lot of play there in safety margins around where the tether would be based. And the third point about the cost, yes, the plan from SpaceX and others is to get the cost of rockets down, at least to orbit, several $100s a pound. We have seen as low as just over $100 a pound. The space elevator powered by space-based solar, we think could do it for about that price per ton of cargo and about $1 a pound per person. So an order of magnitude or more less than their most optimistic. And on the other side, you don't have to ride a modified nuclear missile to orbit, which is handy if you want, you don't want to do that.
Yeah. I'm usually a super mega optimistic person when it comes to things like when it comes to technology and science. But the elevator one, I have to say, is so hard for me to really get fully behind because we've seen nothing like it. Would you, i.e., I would have thought that with a technology like that, we would have seen we will see moon elevators and maybe even Mars elevators before we attempt the Earth one.
Almost certainly. We have been working. One of our proposals is to do a moon elevator as a demonstrator. Ideally as fast out of the gate as possible, because from what we can tell, talking with whether it's the Space Elevator Consortium or a Liftport group, that they could theoretically do that with current technology. And so that would be no doubt one of the first ones. And I agree with you on the viability of the space elevator. It is almost certainly not going to work. When it doesn't, we try again, because to do it the first time, we will have had to create this network of advanced materials fabrication, hundreds of thousands of people employed in those, and all of the material that can't be used for this elevator because it's not good enough can be repurposed for everything from airplane skins to smartphones. So it's as close to a no-lose proposition as we can get, again, so long as we don't hit anybody on the head with the tether when it falls.
I was about to readdress that point, because you obviously said that quite earlier on, that you weren't that you'd already been advised not to hang your hat on the space elevator, so it's more about the ambition of doing a moonshot project like that basically you've kind of got nothing to lose, because the worst case scenario is you end up with an infrastructure that's insanely useful anyway. Yeah. Which is kind of how I see Apollo. You went to the moon, but for no real purpose other than the fact that you've been left with something that's generated far more money than it cost in the first place.
Yeah. And the idea really is to, like Apollo was this camping trip, now it's time to create the ability to actually move to space and do house hunting and do no kidding construction.
Yeah. So, I mean, do you think that the space elevator is a necessity or something that would be great to have? Because presumably we've only got to the first 10 years. Presumably the next decade after that and the decade after that, you have a kind of vision of what then happens once you've you've built this infrastructure.
Yeah. And so, no, the space elevator is not necessary. What's necessary is making the getting to space boring, turning it into the same sort of easy process as New York to London, where all of the time and energy of workers going to space can be spent innovating in space. And so the 2030s and on, we see the explosion of asteroid-based mining, the development of the Lagrange points, both as manufacturing hubs and refueling stops for follow-on transit. Elon's plan to settle Mars is supported by this. One of the things that we've been throwing around is there a role for government in investing in a sort of subway system between here and Mars, Aldrin cycler sort of system? It's our view that yes, but how that happens, we're not entirely clear, and the sequencing of that isn't clear. But by the 2030s, there is no reason why we shouldn't have hundreds, if not thousands, of people living in space, treating it probably like a deep sea drilling rig, where it's a temporary 9-month to a year thing, but they're living there and it's permanent habitation. There are a lot of challenges to that, but there's a lot of challenges to sailing a boat anywhere or going on a walk.
Yeah, I know, absolutely. I mean, the real end piece. Am I right in saying really that the foundation then is you've got all these different efforts, because you've got the efforts of the Zubrins and the Musks, et cetera, that have been talking about all these things, and you've got the ambitions of asteroid mining companies, and you've got the ambitions of NASA and China and everyone else, and you've got all these ambitions. But would you say that the foundation then is much more of a kind of is sitting in American government and actually sort of saying we've got to be serious about all this and be more focused, so it becomes a kind of focal point for all those ambitions that at the moment, for want of a better word, floating out untethered?
Yeah. We are proposing this infrastructure administration be that sort of capstone, that linchpin between the government and private space, where whether it's from regulation to investment, there is a single focal point for private interests to come to, and then for government to feed into. There's no reason Space Force needs to be coordinating launches with 10 different entities. There's no reason NASA needs to be doing the same for proposals that are completely unrelated to exploration. So their budget gets tied up with things like the International Space Station. If that's freed up because that it's commercialized, the government remains an anchor tenant in a civil manner instead of using our exploration agency. Now government can be more focused in what it's doing and stick to the missions assigned rather than just kind of holding it together with tape.
You've spotted the kind of the missing ingredient of how you get this change through. That I'm sitting here thinking, isn't that what NASA do? And then just like you said right at the beginning, I'm thinking, no, it's not what NASA do at all, is it? So I kind of get it. Blue Marble Week. What's Blue Marble Week?
We don't know what needs to be done in space. Our vision is that we need space access, we need space sustainment, we need space support. What those exact projects are, we know some, but there is far more than that we don't know. And Blue Marble Week, at least for its initial running, is a shameless crowdsourcing attempt. So in January, when the US Congress convenes, we will be going to them with proposals for the larger infrastructure administration. And Blue Marble Week is a chance for companies to present a mix of TED Talk and Silicon Valley pitch, where the premise is you have 4 years of dedicated funding for your project. And we have a list of infrastructure-related topics in access, sustainment, or support. How does your project move ahead? Don't tell us that it's all unicorns and rainbows after 4 years. If it's just you've pushed the ball further, then you've pushed the ball further. It may be that it's still useful, but condense this down into a short talk, a short set of slides. We don't care about your math. We don't care about your physics. We care about what kind of results can you expect. We will then take that and walk it into the halls of power and say, this is what you can get for this amount of money. We want 10 billion over 5 years. But if you bump that up, by this much, here's what you can get extra. You want to cut it? Okay, this is what has to be cut.
Yeah. So how on earth do you get the credibility to do that? I mean, particularly these days, it seems, it's very, there's so many people vying for so much money, and everyone's had their fingers burnt in Kickstarters and everything else. How the hell do you build up the credibility to say, look, this is what I'm telling you. This is, how about it? I mean, how do you, yeah, what why would it, I guess the big question is how does the foundation get that kind of credibility to be able to make those claims?
So for one, we are very upfront about being the open, honest, and transparent, that we aren't the smartest ones. We aren't the ones with all solutions. And we are just the ones that are in the right place at the right time and want to connect people so we can build something bigger. The credibility thing is currently and will be even more an issue. Everybody wants to sell something. We have seen that throughout this COVID time, and also just as we're starting up the foundation, I probably get 20 calls a day asking if I want to buy something related to a small business, something or other. But we have committed to being completely transparent. All of our registration documents are posted on our website. All of our expenditures and our planned expenditures are updated weekly on our website. All of us want to be involved in this frontier administration when it's created, but at the end of the day, we're here to move the ball forward. And if we're not, we're not. And so at this point, most of our credibility comes from the humility and openness that we've demonstrated, and the rest comes as we build the team of people who put their faith and trust in the idea.
Yeah. So where have you been finding the team from, and is there still space for people to get involved? Yeah.
So the team, finding the team, mostly looking through whether it's news postings or research articles about these different projects, everything from space-based solar to X-ray navigation. And we just reach out, whether it's me, whether it's one of the team, and we let them know, here's what we're doing, here's our plan, can we talk to you more? And 9 times out of 10, that's been how we've connected. The rest has been referrals from those people. But how can people be involved? The number one thing is talking about what we're doing. It doesn't have to be about us, but the idea that space is normal is only hard because we're not there. That is the number one thing we need. Yeah, we need donations to keep the lights on, and we need people who know how to do, whether it's the policy, the engineering, the social media. But at the end of the day, every person talking about what we're doing is one less person we have to target with ads. And so that's what we want. And so they can reach out on the website at Climb to Space, climb2.space. And I mean, we've had people reach out and say, hey, I think your space elevator idea is horrible. Here's all the reasons. And some of them have been good points. And that's how we've come up with answers to concerns people have. We wouldn't know to come up with the answers or go back to the engineers unless people asked or commented. And so it's not that there's no bad comments, but most of them are useful.
Yeah. Yeah, so I'm going to ask you two frivolous questions that I ask every single guest to wrap this up. Do you have a space-related hero that inspired you to get into all of this?
The father of the space elevator idea.
Tsiolkovsky.
Am a huge fan of his attitude that why can't we do this? Let's of course we need this. We have, towers in cities, so we want to go to space. So of course we just build a tower all the way. Let's just do it.
Yeah. Tsiolkovsky is such a visionary.
And he was treated like Tesla, sort of badly.
Yeah, no. Yeah, none of those Russian dudes had a particularly nice time, has to be said. Final question. Do you have a space song for our space song playlist that we have?
The only thing I can think of is Rocket Man, and I'm not a fan.
You can give me any piece of music. It doesn't even need to be space related, because it could be a piece of music that you listen to when you think about space. Or
yeah, that's fair. I listened to Cocky by Kid Rock.
Nice. Well, I tell you that I'm pretty certain that's not on the playlist so far. So
there you go.
It's going to go on. It's going to go on, and everyone's going to say, "What's that on there?" And I'll go, well, you have to listen to the podcast. Thanks very much for doing this.
Gladly.
It's a really interesting idea, and maybe it'll inspire someone to do the UK version over here as well, or the German version.
There we go.
The Interplanetary podcast is alive!
There you go, Chris.
Fantastic.
That was Tim Chrisman.
Fascinating stuff, man.
I must admit, I massively admire his chutzpah there. I remain very dubious about space elevators, although I do like the whole idea of putting money into things that are very, very speculative, because you're going to get all these technological payoffs from it.
Yeah, absolutely. But I'd say it's incredibly ambitious, I think I'm the same as you. I'm a little bit skeptical about the whole possibilities there.
Chris, if people have enjoyed the podcast, where can they go? I don't say go f themselves.
What I would do is I would open one of my many devices, go to my browser and type in interplanetary.org.uk.
And if they wanted to get even more involved in the journey, they can go to www.patreon.com/interplanetary and become a Spodcat.
Oh, we love you, Spodcats.
Big times. The Spodcats are legendary. A couple of the stories, of course, came through the Spodcats this week.
Fantastic.
On the Discord channel. Oh, what are you doing this week, Chris?
Well, I've got a few things going on. I'm about to go out for some food because the sort of lockdown is going to become a little bit more in Oslo from tomorrow, so we're going to just go and enjoy a little bit of food and drink, and then tomorrow I'm going to record the first episode of my new podcast.
It's called Jamie and Chris's.
Jamie and Chris's Space Podcast. Amazing, featuring Julio.
No.
But it's actually called the Best Movies Start Outside, which is based around my granddad Harry's theory that the best films started with exterior shots. So I'm going to aim to prove or disprove my granddad's quite a tenuous theory. So it's basically a film podcast.
Excellent.
Yes.
I'll be recording the 5th episode of my new podcast, Recovering Queen, tomorrow. And then we're going to start releasing them.
You're Queen Daft, you.
Big time. Queen Daft. So we're going podcast mental at the moment. This is great. I like it.
It's an exciting time for poddies.
Well, can't wait to hear the poddies.
Well, thank you very much.
Yes. I think that wraps it up. It's been a long episode, otherwise.
It has, yeah. It's been very enjoyable as always, Matthew.
Bye bye, Spotcats.
Bye, Spotcats. Bye, Spotcats. Bye, Spotcats. Bye, Spotcats.